Hi, welcome to this video where I will show how to solve the prime factors exercise using Python. So let's go right into the editor here. So I'm going to divide, now it's really loud for me, this drilling. If you're there, Sebastian, can you hear the drilling through the, I have to redo this. Can you hear the drilling through the microphone? It's really loud for me. But I'm not sure, and this microphone is really good at blocking exterior sound like that. So I'm not sure if it's audible, but I will. It was really annoying, so I'll start again here, and hopefully, I guess I'll just push through this video even if they're drilling. Let's do another start here. Okay. Hi, welcome to this video where I will show how to solve prime factors, the exercise prime factors on futureskill.com. So let's jump right into the exercise here, the IDE. So there's another video where I explain what it's about basically, but it's as easy as this or simple as this. You get a number and we should return all the prime factors. The prime factors need to be in sorted order, ascending order, like it says here. And yeah, the same prime factor might occur twice, and then it should be twice in the list that we return. So I'm going to solve this in 2 steps. There is also another exercise called the Sievert-Eratosthenes. So I'm going to use that to get my prime numbers. And then after that, I will go back to solving this one, get prime factors here. So let's first do the sieve. Okay, so now I've written the method get primes here. The static method just means that we don't need the class that we're working in, the solution class here. So there is no self at the beginning when we define the get primes method, but we do send in the largest needed prime, the largest number to look for a prime at, like so. Then we start off with a list which is empty, where we're going to collect all the primes, this one. We do an int. In case we don't get an int there, just set it to max number, the int of this one that we get in. A little bit unnecessary, but anyway. And then we follow the method in Sievert-Eratosthenes. So we create another list by doing a range here. So we start, this is actually a little bit different from the exercise we have on the page, where we start from the number 1. In this case, we start from the number 2. So we're going to basically, from this range here, we have max number plus 1. So if we were to call the method with max number set to, let's say, 5, for example. So look, I'm just going to show now this range method here. So it goes from 2. If max number is 5, we get 6 here. So then it would be 2, and the second parameter would be 6. So what we would get then is a list which looks like this. Let's go with white here. 2, 3, 4, 5. So this is, this is what the list of possible primes. We're going to say that we know that 2 is by definition the lowest prime, so we're going to start from 2. And if we look here, this will be the result if max number is set to 5. Then we'll get the list 2, 3, 4, 5, like I drew there. Okay, and then we just decide that, okay, 2 is the first prime, so a little bit cheating there, starting off with the first known prime. And then we say that while prime is not set to -1, which we'll come to in a second here, why it's not -1, then we just append or add the prime that we have at the end of the primes list that we initiated with an empty list. And then, as the comment says here, we're gonna cross numbers off this list, like the list we just saw, 2, 3, 4, 5, for example, by setting them to 0. So we're gonna use again a range function here, where we start from the current prime. That's the first one to cross off because we already added that to the list. So we're gonna cross off 2 in the first example that we have. We're going to go again to max number plus 1. So if max number is 5, we're going to go to 5. And the way the range function works, you you have to do +1 to actually reach 5. That's the way it works. And then this is the step. So we're gonna do all multiples of prime. So if we do our little example that we see here on the screen, it means that we're gonna first cross off the 2. That's the first number that we will get here. So we will set, okay, so I'll draw the indexes in yellow here below. These are the indexes, x. So it means that in the first pass here, when we have prime 2, we will set, first we will get 2 in number. 2 minus 2 gives us 0. That is the index for the 2. So that one will be set to 0 as I'm drawing there on the screen. Then we will take the step 2. So 2 plus 2 is 4. 4 minus 2 gives us the index 2. So we will set the 4 there to 0 as I'm drawing now. And then, yeah, that will be because then the next one would be 6, but we said that max number was 5. So 5 plus 1 is 6 here. When we reach 6, that will be too large. So we will only set 2 and 4 to 0, basically, in this line here. So 5 will remain as I'm drawing there on the whiteboard. And then we do this line here. So the next function in Python takes an iterator. An iterator it's very similar to the range function, actually. I mean, yeah, range is even an iterator, but one way to do it is using kind of list comprehension here. So we say I for I in sieve. If you remember, sieve is this list here where we're crossing off numbers that we have also on the blackboard that we see here. This is also sieve. Maybe I should write that. This is our sieve. So what we're doing here is we are saying that we are looking for the next number from left to right, so to say, from the start of the list, which is not 0. And this is our iterator. So it will, the next function here using this iterator will give us, in this case, the 3 that we have here. So the 3 that I was drawing a circle around or a box around. Can use another color. This 3 here is the one it will find. So this basically gives us the next prime from the sieve. If there are no more numbers in the whole sieve, which isn't 0, then it will return -1. And that's where we use this in the while loop. While prime is different from -1, we continue to add new primes to the list of primes, and we keep crossing off numbers from the sieve. So the second round here, then it will find the 3, as we see here. And then it will do a new pass here. It will add the 3 to the list of primes, and then cross off all the multiples of 3 in this loop here. And then it will find the next non-zero number, which will be the next prime. In this case, it will find the 5. And in the end, it will return all the primes here. But I can also press run code. I did a little printout here with all the primes up to 100. Of course, I will fail the actual exercise, but we can at least see what we get here. Yeah, so this seems like a legit list of primes: 2, 3, 5, 7, 11, 13, 17, 19, 23, and so forth. So the get primes method seems to be working fine. I should move it like this so it's more visible, actually, all the way. And it's called twice. That's because there are 2 test cases here. And then you can see in the canvas that we are missing on the 2 test cases here, and we are getting 0 to 2 points. But now let's go back and implement the get prime factors here. That's the next step, using the primes we have here. Okay, so what do we have here? Yeah, we printed the primes, but we can maybe skip that for now. So we start off with an empty list of the factors. That is what we're going to return in the end here. We set largest needed prime to num plus 1. Yeah, because I guess what could happen is that the number we get sent is a prime, and then you should just return a list with that prime in it. So maybe I said something wrong before. You have to have all the primes up to the number itself, at least to do it in this way. Then we get the primes from the method we did before up to largest needed prime. And then we start off. I'm going to do while loop here while remainder while there is still a remainder larger than 1. If you remember from our example we did here, when we reached 1 here, then we were done. So this is why we have that as the condition there. So that's what I'm going to set up here. So first we pick up the first prime. So this is going to be 2. That's the first available prime we have. And we start off with the remainder being the whole number, the whole input basically. And then we do this. While we still have a remainder, we're not getting the number 1 yet. Then we check if the current prime is an even divisor of the remainder, the number we have left. So that means that if remainder modulo prime is equal to 0, then we have found a multiple or a divisor. So then we should add that prime to the list of factors. And we're going from the smallest prime to larger and larger. So then we're adding that to the list of factors, since we had an even divisor. And now we update the remainder by actually executing an integer division, where we do remainder integer divided by prime. So here we basically, if we look back into the whiteboard here, we are basically taking a step here. We found an even multiplier like 2. Then we carry out the division, 364, which was the remainder, divided by 2. Then we have a new remainder, 182, and then we continue from there. So that's what we're doing there. Or the other thing that can happen is to say that the current prime is not an even divisor of the number. Then we go to the next prime. So we increment the index in our list of primes to the next number, the next index. And we pick up that prime, just to make it more readable actually, just take primes of x prime. And then we keep doing this, actually basically the same that we see on the screen there in the whiteboard, until we are down to 1, and then we will return factors. And we're actually sure that the number we get in is going to be from 2 to 10,000. So we're not going to get the number 1 as a number. I guess 1, I don't know what we should have returned then, because now it's going to be an empty list, which is maybe funny. But anyway, let's try the code now and see if it works. So I'm going to run. And yeah, it seems that we're home free. We solved those first 2 test cases, which are the same that we looked at on the whiteboard. So now we can proceed to level 2 here. Then we're going to get 2 random inputs from 2 to 10,000. That's how we're going to pass the whole exercise. So I press run code again. And now we got 3,925, which was 5 times 5 times 157. A little bit larger prime. And then we got a similar number actually, 3,871. And that is 7 times 7 times 79. And you see we answered the same. U is the answer we have, and correct is the answer we should have. So we passed, we got 2 out of 2. We can actually, assuming we were lucky, we'll press run code and try one more example, see what we get. But we have already passed the exercise. So the first time we get through this with random numbers. So now 4,815, you can get the prime factors like so, and 1690, then we have these prime factors, double 13. Isn't that lucky? So thank you for watching this video on how to solve the prime factors exercise.